compulsory should know these three definitions, and surely we can expect one question from this ideal and non-ideal solution. Sorry, spelling mistake is there. Okay, and then in second chapter, electrochemistry, the most important thing is Nernst equation. Every year we can expect one question from the Nernst equations. Okay, that E is equal to E naught cell minus 0.0591 by N into log Kc. Kc is nothing but a concentration of the product by concentration of the reactant. So we can expect what is this N? N is nothing but number of electron transferred from one terminal to another terminal. And Faraday's first law. Okay, how much amount of the substance deposited and the current required. On 1 mark question we can expect. And the effect of dilution. This conductance, conductivity, molar conductivity. Either direct problem will come or indirectly we can expect questions from the effect of dilutions. What will happen when dilutions? Okay, whether conductivity increase or decrease, what about molar conductivity? And at last this Gold's law. Okay, every time we can expect. So before that you should know limiting molar conductivity, and limiting molar conductivity we calculate by using this law we can study. That is another thing. And the chemical kinetics chapter, very easy chapter, scoring chapters. Okay, there is no difficult calculations like solutions, very easy calculations only. Mostly we can expect units of rate constant. Rate law will be given. From that you're supposed to find the order of reactions. Sorry. Yeah, so from that we're supposed to find the order of reactions. And rate constant, rate law, first order, zero order kinetics. Moreover, graph based questions like whatever the equations are given first order, zero order kinetics, that kindly convert into y is equal to mx plus c. So slope will be asked or intercept will be asked. What are the equations given that convert into y is equal to mx plus c? And D and F block elements. In that F block elements is completely memory based concept. Okay, so little more memory based concept. In case of D block element, some basic definitions are there, like melting point, okay, color, way transition element form complexes, alloy formations, catalytic property, and the E naught concept. One question we can expect from the E naught question, E naught concept. And this color and magnetic property almost similar answers. Color, presence of color. Okay, why the compound is color? Presence of unpaired electron. Why the compound is paramagnetic? Presence of unpaired electron. Okay, colorless, absence of unpaired electron. Diamagnetic, absence of unpaired electron. A magnetic moment is high, presence of unpaired electron. So unpaired electron, if you know unpaired electron, almost you can answer. Then second half is balancing the equations. 1 or 2 questions every year. Okay, either directly or indirectly will come. Balancing the equations you already studied in class 11th standard. It is not that much difficult, very easy only. Some important balancing equations are given, and I given chromic chloride test also. In practically you performed this experiment to confirm the chloride radical, and a preparation of potassium dichromate. Direct word problems will come starting from FeOCrO3, how we can convert into K2Cr2O7, and this lanthanide contraction consequences, actinide contraction consequences, very easy. Okay, lanthanide contraction, imperfect shielding of 4f electron. In case of actinide contraction, imperfect shielding of 5f electrons. Okay, lanthanide contraction due to imperfect shielding of 4f electron. Actinide contraction due to the imperfect shielding of 5f electron. So that is one of the most reasons behind this one, 4f and 5f electron and imperfect shielding. Okay, that is a reason behind this lanthanide and actinide contraction and the consequences. So most repeated question, zirconium, hafnium and mercury have similar atomic size. Why? Because of lanthanide contractions. Okay, and the common oxygen state, lanthanide plus 3. And what is oxygen state of actinides? Like that question we can expect from these topics. And the coordination compounds, okay, 7 mark, very easy chapter. Okay, among the inorganic chemistry, coordination chemistry, very easy, purely concept oriented. If you know concept, easily you can score out in this chapter. The most important topics of this chapter is Werner theory. Okay, Werner theory, valence bond theory, especially hybridization, geometry, magnetic property. Kindly study for coordination number 4 as well as coordination number 6 also. Coordination number 4, coordination number 6 also you have to study. Yeah, and coordination number 4 means we have two geometry. One is square planar, another one is tetrahedral. Okay, as like as coordination number 6, this is for 4, and coordination number 6, okay, octahedral only. In that octahedral, again two are there. One is outer orbital complex, another one is inner orbital complex. Outer orbital, and another one is inner orbital complex. And crystal field theory. Okay, especially we can expect d orbital occupations. What is a d orbital occupations? A crystal field theory of octahedral complex, d orbital occupations, and some basic definitions. Okay, coordination number, oxidation state, what is ambient ligand, okay, and chelate ligand. If you know ambient ligand, you can surely study the linkage isomerism, and IUPAC name you can write it, and we can expect some ionization isomerism. Okay, ionization isomerism mostly will come from Cl minus and SO4 2 minus. Okay, what is the confirmatory test for Cl minus? Nothing but AgNO3 test. It gives cardio white precipitate. For sulfate, BaCl2 test. It gives white precipitate. Already performed in practical. So based on this one question, we can expect from the ionization isomerism. So next, organic chemistry. Okay, as of now, you didn't study organic chemistry. Not an issue. You can easily make it. Okay, organic chemistry. Already I told you study in 5 different part. One is IUPAC name. All IUPAC name at once. Okay, then name reactions. Very okay, nearly 25 name reactions are there. If you are unable to study at least some important name reactions, and distinguish between pair of compound. Two compound will be given. How to distinguish that you have to study. If you study almost this, okay, of how the organic chemistry is over, then reason based questions. All reason based questions at once. That is very easy to you study. And at last, mechanisms. Okay, so entire organic chemistry we can divide into 5. IUPAC name reactions, distinguish between pair of compound, reason based question, mechanism. At last, converse. If you are very good at reagents part, then you can go for conversions. So some important topics only I am giving. S1 only, S1 2. Every time we can expect one question. And the reactivity order. What is the reactivity order? So already we discussed. Okay, nothing but sorry. Okay, S1 sorry. So S1 tertiary, secondary, primary. Stability of carbocation. Okay, SN1 always you have to check stability of carbocation. In case of if you want to check SN2, okay, easily check back bonding effect. Whether nucleophile can easily attack the back bonding. Okay, that only you have to check. That will be easy. Compare then S1 and SN2 order you can easily find. One small example I am explaining you. Okay, CH3. Okay, Cl is there. So some nucleophile is there. Nucleophile means nucleus liking power. It may be negative in charge. Okay, it can easily attack from this two side. In case if I am taking tertiary. Okay, tertiary butyl bromide. So nucleophile is there. Okay, this alpha carbon already connected of the 3 bulky group. Nucleophile cannot easily and attack. So this is a way you can easily find. So in case if you are unable to find SN1, no problem. Write SN, find SN2 order and write in reverse. That is very easiest way. Then optical activity and some important named reactions. Okay, that will be given. Okay, and boiling point. One question we can expect, okay, which have more boiling point and why? So this is the order. Kindly remember this order: alkane, ether, haloalkane, aldehyde, ketone, amines, alcohol, carboxylic acid. This is a boiling point, and very important thing. It is applicable only for comparable molar mass, open chain compound, same number of carbon atoms. Okay, in case of different number of carbon atoms, kindly don't follow this one. Okay, for all those things you can give one simple reasons. Carboxylic acid. Why carboxylic acid have more boiling point? Dimer. Why alcohols have a more boiling point? Intermolecular hydrogen bonding. What about amines? For amines also intermolecular hydrogen bonding. If the question is between amine and alcohol intermolecular hydrogen bonding is more polar because oxygen is more electronegative than nitrogen. Like that, we can give simple answer. If the same function group is there, okay, this is one of the blind method to shortcut. Boiling point is directly proportional to number of carbon long chain. More number of carbon atoms are there in long chain, it has high boiling point. Okay, when it have more branches, it have less boiling point. In halogens, depends upon the size, or we can tell directly proportional to mass. Okay, this is the order applicable only for same number of carbon atoms and open chain compounds. Okay, so next, okay, some name reactions. Every time one or two name reactions will come. Name reaction slide I will upload separately. Okay, tomorrow evening I will upload. And alkene with HBr in presence and absence of peroxide. Actually, this is in class 11 standard. Okay, margonic of good, anti-margonic of good. We can expect. So next, okay, ethers with HI. What will happen in ethers with HI? And phenol to benzene, benzene to phenol. This ethers with HI, okay, every time we can expect simple concept ROR, okay, HI. So commonly we can write, so this will become RI plus ROH. But here only one conditions. If this R is secondary and tertiary, it will follow S1 mechanism. That means stability of carbocation. Carbocation stability. Okay, in case both alkyl group, okay, both alkyl groups are primary, then it will follow SN2 mechanism. So this is the thing. In case of aromatic compounds are there, okay, any compound, any atom connected with the aromatic chain, there is always partially double bonded character. Okay, so we cannot remove it. For example, anisole. What is the formula for anisole? C6H5 OCH3. So what will happen when with HI? There are two possibilities. Either oxygen can go along with benzene or oxygen can go along with the methyl group. But there is a double bond, partially double bond between this benzene ring and oxygen. We cannot easily break. So the product is always phenol plus methyl iodide. Okay, reason behind this one, this oxygen is a partially double bonded character with the benzene ring. This is not only for oxygen, any atom, okay, connected with the benzene ring, always partially double bonded character. Okay, then some distinguish between pair of compound. Every year, one or two questions will come. Okay, Lucas test. For what purpose Lucas test? Okay, Lucas test for the distinguishing of primary, secondary, tertiary alcohol. Okay, bromine water test. Bromine water test for phenol and aniline. Tolerance test and Felix test for aldehyde. Iodoform test only for methyl ketones. Aldol condensation. Presence of alpha hydrogen and absence of alpha hydrogen. This is absence of alpha hydrogen. Okay, bicarbonate test. Test for carboxylic acid. Carboelement test. Test for primary amine. Okay, RNH2. Hinsberg test. To distinguish primary, secondary, tertiary amine. Primary amine RNH2. Secondary amine R2NH. And tertiary amine R3N. Dye test. Okay, in case both are primary amine, one is aliphatic, another one is aromatic, so you can use dye test. Simple questions. Distinguish ethylamine C2H5NH2 and aniline. What is the formula for aniline? C6H5NH2. How will you distinguish? Both will undergo carbonyl test, both will undergo Hinsberg test. You cannot distinguish, but by using dye test, you can distinguish, okay, ethylamine from aniline. So compulsory one questions we can expect from this topic. Okay, please study and go. Don't leave any of these topics. Okay, so next, some recent based questions are given here. Acidic strength, okay, pKa order, and why phenol orthocosal metacosal, carboxylic acid, benzoic acid, and the reactivity of formaldehyde acetaldehyde. All those things. Simple concept. Okay, how can you remember all those things? EWG, more acidic character. And why aromatic primary amine cannot be prepared by carbohydrate synthesis. And electrophilic substitution reaction of aniline. Because even though NH2 is ortho para-diacting group, we will get some meta-diacting group also. Why? And properties of benzene disonium chloride. Compulsory study and go. And Hoffman bromide degradation. Okay, so next, basic strength. Every year we can expect one question from the basic strength. Okay, these are the topics. Okay, and then some general order I am given. In case of R is ethyl, this is the order. R is methyl, this is the order. For gaseous phase, always tertiary more than secondary than primary. This first is only in in protic solvent solution. It is applicable for gas. So next, biomolecules. 7 mark solid you can get. Okay. Some important reactions: glucose with HI, Br2, HCN, hydroxylamine. All those, okay, this HCN and hydroxylamine already studied in aldehyde ketone carboxylic acid chapter. Once again, just to revise. And hydrolysis of disaccharide. On 1 mark, we can expect, okay, any disaccharide or trisaccharide under hydrolysis, what type of product we will get. And the reason behind this cyclic structure of glucose. Okay, then proteins, classifications. Okay, essential, non-essential, acidic, basic, like that. And denaturation of protein, diet questions. It is easy to biology students. Other than biology students, little bit you have to memorize difference between fibers and global protein. Peptide bond. Every year we can expect most one question from this topic. Peptide bond and a glycosidic linkage, sweater ion, isoelectric point. Okay, these are topics are somewhat very important. And vitamins from lower class onwards you are studying, okay, fats and water soluble vitamin. Simple things remember. What is water soluble vitamin? Okay, uh, C and B. Remaining are fat soluble vitamin. And a nucleic acid like nucleotide, nucleoside, DNA, RNA structures. Okay, all these topics study and go. All the best.